Hello, so today we're going to find out what the number 3.14 really means. So if I asked someone today, they would probably say, well, it's pi. Now, it's not the dessert pie, but it's pi in the mathematical sense. And pi equals the area of a circle. But why does this number 3.14 equal the area of a circle? Something that we will grow to understand. We will do this by using triangles. Pie slices. Hopefully I'll draw some better ones further on. Okay, let's start by using 4 triangles. 1, 2. Let's start by using 4 better triangles. And 1, 2, 3, and 1 really odd looking triangle. So pretend these are even triangles. And let's put a circle over top of this. So we're going to use these triangles to approximate the area of the circle. Okay, let's use a radius of 1. And let's find out the area of one of these triangles, this one here. We know that the area of a triangle equals 1/2 base times height. So the area of this triangle here, just the one, would be 1/2 base. Well, the radius is 1, so the base would be 1 plus 1. The base would be 2, and the height would be 1. The area of one of these triangles equals, well, these 2's cross out, 1. The area of 4 of these triangles would be 1 times 4 is 4. So this circle is approximately, the area is approximately 4. Let's take a look at a circle that's made up of 5 triangles now. This one is going to be trickier to draw, so bear with me. Oh, not too bad. Let's put the circle over top. So a circle made up of 5 triangles. This radius is going to be 1 again. Oops. One. And let's put our triangle formula back up here. 1/2 base times height. Okay. So let's bring out one of these triangles. Let's bring out this triangle here. Let's put it right there for us to see, nice and close up. Let's take a closer look at it. We know that if we cut it in half, this would be 1 because the radius of this circle is 1. From there we can see that this forms a right angle, 90 degrees. Now what else can we figure out? Well, we know that a circle is 360 degrees. So we can find out the angle of this by dividing 360 by 5, since there's 5 triangles. 1, 2, 3, 4, 5. 360 divided by 5 equals 72. 72. And we're going to split this up in half so we can get this angle, which is 36. 72 divided by 2 equals 36. So we have this angle here is 36. This side is 1. The length of it is 1. This angle is 90 degrees. Well, it'd be helpful to have the base so we can plug it into this formula up here. So let's find it out. We can find it out using the SOHCAHTOA method. SOHCAHTOA. And we're going to pick out TOA. So we will do tan t, 36, we're going to use that angle, equals opposite over adjacent. The opposite side of 36 is this side, which we don't know. So we're going to leave it as O. And it's going to be over the adjacent side, which is this side, so that will be 1. So we can just ignore the 1 because we know anything divided by 1 is itself. So the opposite side, or the base is equal to tan 36. So this side here is tan 36. And in order to get the full base, which will help us over here to get this full base, we're going to do 2 times tan 36. So base equals 2 times tan 36. Great, so we have the base, we have the height. That means we can plug it back into this formula. Area equals 1/2 base 2 tan 36 times height 1. Great, so this equation will help us figure out the area of one of these triangles, this one. But we need to know the area of 5 of these triangles. 1, 2, 3, 4, 5. So we'll have to times it by 5, or it will actually equal 5 over 2, but we can just do that to make it look easy. So the area of this circle, the area of 5 of these triangles will equal A equals 5 over 2 times 2 tan 36 times 1. And if we plug that into our calculators, it'll actually equal 3.6327. And if we can recall from when we did this using 4 triangles, the area of the circle was around 4. So what we notice from these two numbers is that we're slowly making our way to pi. So the trend is, the more triangles we add to form a circle, the closer it gets to pi. Okay, so let's take a look at this. So when we used 5 triangles, n equals 5, the equation was 5, the equation of the area of that circle was 5 over 2 times 2 tan 36 times 1. It was 1/2 times 5 times base times height. Now let's take a look using 6 triangles. N equals, actually let's use 8 triangles. Might as well jump up there. So n equals 8. Well, we know eventually we're going to times it by 8, since in this scenario we times it by 5. It's going to be A equals 8 times 1/2. Now, what is the base? This is where it gets tricky. Well, in order to find the base of one of the 8 triangles, we're going to do 2 tan again, but the degrees are not going to be the same, because 360 divided by 5 was 72. We split that in half to get 36. That's where that number came from. But now we're dividing 360 by 8. So it'll be 360 divided by 8. And remember, we need to double that because 36 was half of 72. So it'll actually be 360 divided by 2 times 8. And then times 1. So this is the equation for a circle made up of 8 triangles. You know what, I'm not even going to attempt to draw that good. There you go, 8 triangles, pretend. And this equals 3 point, I wrote it down somewhere, 3.1. So even closer to pi. So we're making our way closer to pi. Let's jump ahead to using 10. So we can gather from this equation here and this equation that there is a formula going on. That formula is a equals, well, normally it would be 1/2, but we're going to put n over 2 since it's going to be the number of sides in the triangle we're looking for over 2. So this could be any number of triangles. Times our base. Our base is 2 tan 360 over 2 times n. 2 times the number of sides in the triangle. And then finish it off times height. So this is our formula. It'll help us get closer and closer to pi in an easier way. So I'm going to rewrite that formula up here. A equals n over 2 times base 2 tan 360 over 2n times height. Perfect. Well, let's plug in some numbers and see if we can get as close as possible to pi. Let's pretend we're using a circle made up of 10 triangles. I'm not going to draw that out again. A equals 10 over 2 times 2 tan 360 over 2 times 10. We'll plug that the end spot, and times 1, which is h. Perfect. And this will actually equal, if we type it into our calculator, 3.249, so on. So close, almost there. Let's see if we can get even closer. Clear the screen. Let's jump way ahead and use, well, let's make n equal 100. We're going to use 100 triangles to form a circle. So let's bring back the formula. A equals n over 2, so 100 over 2 times our base, 2 tan 360 over 2 times our number of triangles, 100, times our height, 1. Area of a circle full of 100 triangles, tiny triangles, will actually equal, when typed into a calculator, 3.14262, so on. Awesome. We reached our number. We reached pi. So what does this tell us? Well, we figured out that pi is actually, it's the area of a circle, but it's also the area of a bunch of triangles that make up a circle. This can help us understand where pi came from, how we got to here, how we got this number to say this number equals the area of a circle. So I hope this helped you out and to understand this number a little bit more. Thanks for listening.